quiz solution, and like I said, everyone took a very different quiz. So I just highlighted the important things and I just made some stuff up. So these were the things that you had to do on the quiz. The first thing to get the first 2 Rubric points was you had to be able to define an array. So you were given a table of data and you were asked to define a numeric array that was 2-dimensional and then a cell array that held strings. And so those are the first 2 Rubric points, is that you define those 2 arrays. A 2D numeric array and a cell array with strings in it. The next thing that you had to do is access parts of those arrays you just defined. So for example, you had to access just one column or just one row. So data 1, colon, does that access the first row or the first column? The first row, that's right. So that's one example of accessing, okay? Then you had to manipulate the arrays, usually incorporating with some function like find or max or some other function. So here I just did a calculation with that array that I just defined, one row, and I just called the variable one row. Kind of gave away my question. But anyway, and I plugged it into the max function. I outputted both the value and the location of that calculation. So that was another thing that you had to do actually several times on the quiz. Then part A, the most difficult part of the quiz, was that you had to add a row to an array. So adding a row to an array, you just access the row that you would like to add. So 3, colon is the 3rd row that doesn't exist. You set it equal to something that's the same size. So you could set it equal to the calculation that you just did, whatever it is you need to put in there. I'm just setting it equal to a mean. I just a percentage. I'm taking the second row and I'm just dividing by that sum. And then the last thing you had to do in the quiz was display. You can either use the disk function or the fprintf function. We are going to soon be done with display functions because we now can plot, but you also had to display some results.
How would, if you're using fprintf and you want to say this number is something percent, how can you actually use the percent sign?
The percent sign is a double percent sign.
Okay.
If you use 2 in a row, it makes the symbol. If you use 1, it tells where a variable should go. So this is it, and if you see, you did all of this in the lab. You did it with just a different example. So typically, the quizzes are going to be set up where everything you already did once in the lab, so you should always look back on your lab sheets as you're working through it if you can't remember how to do something. With the exception that part A, to get an A on the quiz, if you're taking one of them that says part, like some of you might not have taken this yet, but the part A, to get an A, I guess I call it part 3 or something. Anyway, that usually will ask you to do something that you haven't done before, like a slight variation. So last quiz, it was to print a string with the display statement because that was part of the bonus of the lab. It wasn't a required part of the lab. Okay. So for plotting, I wanted to make sure that you see this summary here, and I've summarized some on the slide too, but there is so much with plotting, okay? It's more than any other topic that you should never have to memorize anything with plotting. You always just need to be able to figure it out, look it up, whatever, look back on a previous M file, because it's just a lot of syntax. You should never be expected to memorize it. But the basics are you should be able to plot, label axes and titles. You should be able to change properties using the long or shorthand, and then do basic things to the plot like a legend, add a grid, text annotation, and stuff like that. With 3D plotting, there's only 3 types that we've talked about, plus plotting the image if you've done lab 3, and then just changing the color map and adding a color bar. You're doing a lot more customization in the lab, which just kind of gets you some practice in having to figure out something that you maybe have never done before in plotting that you can't just see with an example. I had a couple tips that I wanted to make sure that you remember to do. The first is close all. I think I told you this last time. Make sure you type close all at the top of your figure. That way any new figure will pop up again. And so you don't have to right click on MATLAB and try to find the figure. The second thing is the set command. I wanted to explain the set command just a little bit. I think some of you have figured it out. The set command is able to change just about any property of a plot. And so even things that you can do within the plot function, you can also do within the set command. So the command is set. The first input that we'll always use is GCA. GCA stands for, I have no idea, but it means the current active axis associated with your plot. So you can actually label your axis when you run your plot command and call on the function that you named it, but we're never doing anything complicated enough where that's necessary, so you can always just put GCA, and that just means use this axis. The next input to the command is whatever you want to change. So if you want to change where the x ticks are, where the y ticks are, where the x tick label is, anything goes in that second spot. And then what you want it to change to is in the third spot. So here we're changing the x ticks to 1 through 5. Maybe they were automatically 1, 1.5, 2, 2.5, but I just want them to show 1, 2, 3, 4, 5. So that will change how the ticks are displayed. The x tick label, if you don't want the x tick label to be a number, or you want it to be a different number, you can actually change it by just setting up a cell array and just setting the x tick labels to that cell array, as long as the cell array has the same number of elements as your x ticks currently have. So here I've set the x ticks to 1 through 5, and I've set to 5 different labels. The set command is a really convenient command, but 2016 version seems to be eliminating it. It still works for 2016, but they have changed how you can do this now, so I don't know if they're going to get rid of this or just add to it. Okay. So I'm going to move over to the .cam. I'm going to have MATLAB open and the .cam open. How's my sweater look? Good. I should just memorize the direction of this. All right. So what we're going to talk about is a new topic, and this is not to scare anyone. This is just real. I'm just being real with you. The class is going to start getting difficult right now. I've been teaching this for 5 years. This is the time when people start to, it's the most challenging part of the semester, because we're starting to learn how to write algorithms, how to understand logic, and how to put it all together. So it's really, really important that your fundamentals are good at this point, that you understand how arrays work, that you understand how to do calculations and all that kind of stuff. Plotting will just help us basically be able to see the results of what we're doing. But you know how in the back of every pre-lab I have you go through and write a pseudocode? And it's been kind of like weird up to this point, because it's weird to write a pseudocode when it's like kind of obvious you're just following directions, doing each task. This is where you're going to really have to start thinking about how you're going to frame the algorithm before you come into class and write out a pseudocode. So I'm going to give you an example today of how that process goes with an example. And we have this, I've split this up into 2 sections, where this first topic 4, we're going to be talking about logical and relational statements and operators. And then the next topic, we're going to be doing loops. And these are the 2 topics, as also the array topic, that are going to be in every single other topic. You're always going to be using logical statements. You're always going to be using loops. You're always going to be using arrays. So it's really important that you understand these foundations. So we're introducing a new data type or class of data in this topic, and it's called the logical class. And this type of class is called a Boolean data type in a lot of programming languages.
And it basically is the data type that either represents a true or false condition. So true in MATLAB is represented with the number 1, and false is represented with the number 0. However, they are not the same as just using the numbers 1 and 0. They actually have associated with them a different data type, which is going to be called the Boolean data type, or the logical class. So we are going to be doing similar things to the find. When you use the find command and you put in a relational operator, it's going to be very similar to that kind of idea, that you're going to be looking at an array and finding when a condition is true inside that array. Question?
What's the word for data type?
Boolean. Like boo as in like boo. Lean. Mm-hmm. Okay. So that's the first thing you need to kind of have as a base, is this idea of 1s and 0s for true and false statements. The next thing are relational operators. And relational operators are used to pose true and false questions. So you've already used these a little bit, but they're all of the operators that can compare two things. So in MATLAB, the syntax for greater than is the greater than symbol. This seems obvious, but other programming languages would use something like GT instead of the symbol. So this is the syntax for saying greater than in MATLAB. Less than. Equals, if you want to check if two things are equal, you need to use a double equals sign. Can someone tell me why you would need to distinguish between 1 and 2 equal signs? What do we use 1 equal signs for? We use it to define things, to define variables. And so anytime you're trying to do a relational equal sign, you need to have 2 of them. And then there's others like greater than or equal to is the symbol greater than and equal to together. And then same with less than. And then the last one that you'll need is not equals. And for that, it is the squiggly, and it's the one right next to the 1. It's the shift right next to the 1, and then the equal sign. So let me give you a couple examples in MATLAB of this. So if I do 5 is less than 3, is that true? No. So you'll see that when I press enter, it says 0 because it's not true. So that was a relational operator and its result. Another example is I could do 5 plus 2 equals 7. So that is true. So when you enter it in, the result is 1. All right, so next we're going to talk about logical operators. And these are used to combine relational operators. So for example, you have one condition that you want to check, one relational condition that you want to check, and maybe another. Oh gosh, why can't I write this? And so the two types are usually and or. So you want to know when this condition and this condition are true, or possibly you want to know when this condition or this condition are true. So the options are and, which uses the ampersand sign, and or, which uses the vertical line. And so just a little bit of logic review, you've probably seen this before. If you have a true statement and you combine it with another true statement, you get out a true statement, right? That's always true. If you have a true statement with an and a false statement, then the result of that logical operator would be what? It would be 0, because and means they both have to be true. So if one is false, then the output of that would be false. Where or, if both are true, then you get out a true. And if only one is true, oh gosh, why am I'm not doing good. And if one of them is true, you also get out a true. So most people have seen that before in like some math class or something like that. What's that? Exclusive or.
Like if only one of them.
Oh, if only one. Yes, it's not a logical statement though. There's a function called any. There might be a function called only, but these are the only two logical operators. But there's functions that do that. Any other questions? Okay. So there's actually two types of logical operators. And this can get a little bit confusing when you start using them. There are the operators, and they're always doubled. And these are what we're always going to use, is the double operator. And it will stop computing as soon as the result is known. So basically, if you have a bunch of conditions and a bunch of true and false statements, as soon as it knows that it can stop, it will stop checking the conditions. So especially with or statements, a lot of times if there's a bunch of ors, if one of them is true, then it will just stop. And that's almost always what we're going to be doing for the most part. If we're using arrays and looking at comparing whole elements where we need to check the entire thing, then you use a single. And so that would be if you're doing like vector comparisons, where you're looking at whether one element in this array is greater than something, or one element in this other array is greater than something, then you would need to go through and check each element. You couldn't just stop at some point. And that's when you use the single. I don't know what I was doing here. Okay. So I wanted to do an example. Oh, no, I'm going to talk about logical indexing before I do the example. All right. So what we've talked about up to this point is we've just talked about the way that you can basically determine whether conditions are true or false, and how you can basically put together the syntax of and, or, and you know, the other one that I should probably add is not. So I'll add that right here. You can sometimes get around it, but not could also be, it's always just the opposite of whatever you put it in front of. So it's just the squiggly again. So we did not equals to, but you could also put an entire condition and then just put the squiggly sign in front of it, and then it would just be the opposite of that. So it would take the opposite. You hardly ever like need it, but sometimes it's convenient to use. So not always does the opposite. So if something is true and you put the squiggly in front of it, it will turn it to a false. Okay, so logical indexing, and this is directly from your lab 4. So I'm going to create a shorter cell array. And this is what we're going to do a lot with logical statements. It's very similar to what we've been doing with find, by finding something and then putting it back into a cell array to kind of display what the result is. You can do the same thing with logical indexing, and actually some of you were doing this instead of using find. I don't think on purpose, but so let's say we have a set of trash. This is a bunch of trash. And then I have an array that says how long it takes for that trash to decompose in years. And this is just from the assignment. I think I used the same numbers. So I'm going to move over to MATLAB and show you at the same time. So if you do years is greater than 350, it will give you, oh, I gotta define years. It will give you, ooh, why did I do that? Oh, thank you. Okay. It will give you an array, and this is a Boolean array. You can actually see here, if I could define this if we wanted to as M. You see how M is showing up as a logical array? And it's the same size as the array that you put into the condition, and it has ones where that condition was true and zeros where that condition is false. So that's what you get out of it. And then what you can do is take and put that logical statement into the array, put it back into itself. So I'm just going to take that condition and I'm going to put that condition inside itself. Year, right? And it will just give you the years that had ones associated with it. So you can also, I saved that output as M, so I could put M in there, it should give me the same thing. But I put those ones and zeros inside the year array, and now I get the values where that condition is true. Does that make sense to everyone? So you can do the same thing with another array that's holding some similar information about the data. So trash, didn't define that either, so let me define trash. So if I have a cell array that has some strings associated with the names of each of those datas, and then I plug M into that array, then I will get out just the strings associated with that condition being true. And you can either save it as a variable like I have with M, or you can just put the condition directly into the array. And so that's what, when I talk about logical indexing, that's what I'm talking about. You're using the logical results to index your array. So now I just want to try this. I actually am not 100% sure what the result of this answer will be. If you just try to create your own logical array by putting in ones and zeros, it's not going to work because those are actually ones and zeros. They're not associated with true and false. And so what it's trying to do here is it's trying to access the first element and then the first element again, and then here it's trying to access the 0th element, which doesn't exist. So you always get this error if you try to use just ones and zeros. I believe that there's a function called logical, if you're ever in this situation where you want to test something, where you can convert ones and zeros to logical ones and zeros. So if you put actual ones and zeros in, the output will be true and false. Any questions about that? Okay, the next thing I wanted to just cover, and you're going to do this in your pre-lab, so I am just going to cover it quickly because we're going to do it much more next topic, but because we're talking about relational and logical operators, I think it's useful to see it now, and we'll revisit it, which is if statements. If statements allow you to check conditions using logical and relational operators and execute code only in situations where you get true conditions. So for example, you say if, you put in a condition using those logical and relational operators, and then you put commands in between the if and the end statement. And those commands in between if and end are executed only if the condition 1 is true. So that's just a regular if statement. There's also an if statement with an else clause in between. And in this case, the commands between the if and else are executed if condition 1 is true. And then here, everything between else and end is executed if condition 1 is false. And then the last type is an if-else-if statement. So you can put together, I'll just divide this up a little bit. You can put together if, else, if, else, and then end. And then here you have a condition and the commands in between if and else if. That works the same. Those commands are executed if condition 1 is true. But then else if gives you the option of writing a second condition that's checked. And so these commands are executed if condition 2 is true. It's in an if-else-if. I actually always forget this. I think it stops once the first condition is true. But I'm not confident enough to say that for certain. Who asked that? Because I'm just looking at random people. Yeah. So I'm not really sure. And then the else behaves the same as up above. So if condition 1 and 2 are false, then it will go to else. questions about that. You'll do a couple examples in your pre-lab, and you can use if statements to solve the lab, but I don't actually think you need them. So I'm going to go through and show you an example, and I'm going to go through this a little bit fast, so you might not be able to keep up with the notes, but you'll be able to look back on this and read it if you miss it. So I'm going to hopefully do this and then program it 10 minutes. Let's see your try. Okay, so what we're going to try to do is write a code that's a grade sorter. So it's going to take in an array of scores, and it's going to categorize those scores into A, B, C, D, and F ranges. So it's going to basically take a score and say whether that's an A, B, C, D, or F. And it's also going to count out of all the scores in the array how many of each score there was. So how many A's, how many B's, how many C's, D's, and F's. So that's the goal of the code. Okay, that's the problem statement. So now what we want to do is we want to go through the steps that I showed you, which is to kind of like solve this problem as you would a human, if you were a human. So you are a human, so that's great. You're ready for this part. So if you were going to do that, the first thing that you would think is, I need scores. So if you need scores, you need to have access to the data somewhere. So if you were a human and I asked you to do this for me, the first thing you would say, if I didn't give them to you, is, I need the scores, right? So that's the human version, and if you convert that to MATLAB version, turn off the autofocus, that means that you need to define the data in a variable. So here I've created a variable scores, which holds all the data. Okay, now you need to determine the conditions which define each range. That would be the next thing you would think, well, what is an A in your class? 90 to 100 is an A, etc. So here are the ranges. Now these are going to convert to relational statements in MATLAB. So if you needed to look at this range here, you would look at when scores is greater than 90. And I wasn't really careful about the equals, which one is equal to, but it doesn't really matter. So when scores are greater than 90, it would tell me which of these scores are ones and which ones are zeros for the A range. Does that make sense? For this one, it would be scores are less than and equal to 90, and then is it and or? An and symbol. I can't write today, I don't know what's wrong with me. I think 1 or 2 ands will actually work fine for this. I said that we don't need them, but we do for this. I think you need to use 1. And greater than 80. So its scores are less than or equal to 90 and scores are greater than 80. And then you would just do the same thing for each one, okay? Okay, so that will get us logical arrays that categorize each range. So we'll have a different array that tells us what each range is. And then we need to specify a letter grade. So we need to say, we've found which ones are A's and which ones are B's, but now we need to record it, basically. We need to say, okay, this element 1 satisfied this range, so that's an A. So that's going to be creating a new variable and filling it in with strings associated with each of these conditions that match it. To count, we're going to take these arrays that we've filled with ones and zeros, and we're going to count them. And so to do that, you can use the sum function and just count how many ones are in each array. And then the last step of just about every assignment that you're going to do is you're going to need to somehow report your results. So that's either a disk function, putting it on the screen or unsuppressing it or something, or plotting the results. So these two are going to be pretty much in every assignment that you do. Somehow you're going to have to read in or define some information, and then somehow you're going to have to report what it is. after you write these steps and kind of just sort through it all, that's kind of like the human style, converting to computer style. Your next step is to write a pseudocode, okay? The pseudocode is to arrange all of this syntax that you kind of roughly converted into the right order. Now, with this example that I gave you, it's in the proper order, but once we start doing a lot of the if statements and loops where you have those if and end statements, you're going to need to nest everything properly, and that's the main purpose of the pseudocode, is to just kind of get it all in place. And you don't need to be really careful about syntax. Like here you can see that I didn't write out like this condition and then the B condition. I didn't have to write each condition out, but I at least have like a rough idea of what I will write out. And then here I've pre-allocated an array, a cell array, that I'm going to fill with the letters A, B, and C. And then here I've accessed this logical indexing that I've created for the A score. And I've put that into the letters cell array, and I've defined each element as an A for when that condition is true. So I've kind of like sorted out how that syntax works. And then for counting, I am just going to sum up the indexes that came out of the logical statement for the A's. So what I'll do actually is I'll write this up and I'll just post it on D2L so you can see the final code and what it looks like, and maybe refer back to some of this. But I just want to stress that it's really important that you do this prep before you come to lab and you think about logically and algorithmically how you might start to attempt the problem, because this kind of stuff just takes some time and it takes, it's different for everyone. Yes.